inverse variation and direct variation. So this here has a lot of different stuff in it.
So it sounds like a hard.
Mrs. Carter, you didn't get the beginning of that. You just started recording.
Oh, that's fine. Okay, so the first one is direct variation. What that is as something goes up, so does something else. So, for instance, the more chocolate I eat, the more my weight goes up.
Yeah.
Direct variation.
No, actually, false.
Yeah.
That must be wrong.
Pretty much. Okay, another thing. Oh, here's one for you. The more homework you do, the higher your grade. Direct variation.
The last paragraph.
Stress level.
Or you look like Nick.
Stress level.
So-
Raises.
You're saying the first one that we're learning is direct variation, right? Then why does it say it first?
There might be. Okay, so as one thing goes up, something else goes up. Now you have done these before. Now think of an XY coordinate plane. As X gets bigger and Y gets bigger, what do you get?
Nothing.
A bigger number. What would you be graphing?
An angle.
Shape.
A square. A triangle. Line. A cucumber.
As one thing goes up, so does the
A
X.
parabola.
X goes up, so does
You're doing
Y.
a straight line.
You're doing a
It's
straight
a straight line.
I said that.
Yes, it is.
I was like cucumber. Wow.
So a direct variation is old. The only thing they're doing here is changing all the vocabulary on you.
Oh god.
So when you go through here, and X goes up, Y goes up, what would that be called that's telling you how fast it's going up?
The
rate. The rate, another word, starts with an S.
slope.
Slope. So they're going to say you're really finding the slope. Well, in direct variation, this is Y equals KX. As X gets bigger, Y gets, so as this gets bigger, Y gets bigger. What's it missing for a line?
Plus B.
Plus
Z.
B. So guess where every direct variation line starts? At
Zero.
Zero. So the B is gone. So everyone, you're going to put a dot at 0, 0, and then you're going to graph the slope, but in this case, they call it K. It's called the constant of variation. It's another name for slope. Nick, remember the part where you can't talk? That would be it right there.
Okay.
All right, so this is a constant of variation. It's always K, it's how it changes. All right? Y equals KX is a direct variation form. It is a line. Okay, you can also do them as ratios, like we do with similar triangles. Like Y over Y equals X over X. It's possible. I am going to teach you this one because it's the easiest. Okay, are you ready?
Then don't even mention. Why?
Here we go. They are in story problem form. No, easy story problems. They're not like crazy long things. So when we go through here, it says Y varies directly as X. These words tell you what it's doing. So if it varies directly, it's the Y equals KX line. Okay, this letter, varies directly is equal K. That's the first thing you write. Now, it doesn't always have to be, I'm doing it now. Now, it doesn't always have to be Y and X. They could use different letters, like A and B.
Yeah.
So whatever the first one is what it equals. And whatever the second one is how it's going
So
over there.
then Y was after that, you put Y after K.
Correct. If it said X varies directly as Y, you would say X equals K Y. That's exactly right. All right. So this is what my formula is. That's step one, is figuring out what you're doing. Well, not really step one. All right. To do this, you just plug it into the equation. They're going to give you two numbers. Okay? You have to find K. After you find K, I'll show you. After you find K, you're going to use that to find whichever point is missing. Okay, so Y equals KX is my formula. So I just plug in Y and X. So what's my thing going to be?
6 over X.
6 equals, we don't know what K is, and we do know what 11 is. What?
How does X equal 11 and X equals 3?
There are two different points on a line.
Find Y.
Oh.
You gotta do it
Does that
twice,
make
Cristiano.
No. a line that has infinite points, right? I can give you any number for x and make you find the value of y.
Oh.
There's like 1,000. So this is the first one. This is your first point.
So like instead of writing the equation, since you're just gonna divide it all by 11 and create a ratio, can't you just create a ratio?
Yeah, but be careful.
The haircut's got to.
All right, so I need to solve for k, so what do I divide by? How do I get k by itself?
11 divided by
11. So step 1, k is equal to 6/11. Everybody good?
No.
Okay, step 2,
I can't.
okay, what is that truly? That's my what?
Your point.
My, okay,
Your
so
slope.
my slope. This is really, you're thinking in your head, slope.
I can't write anything.
Could I graph that right now? Could I graph that line?
Yeah.
I absolutely could. Where would I start?
Could you start at 0, 0?
You would start at 0, 0,
And you go up 6 over.
up 6 over 11, and you would draw your line. Everybody good? Okay.
Hey, can you go
Step
up
one.
again and like move to like the left?
What are you talking about?
It's because his direct quotes, he can't see over your big head.
Move over.
But I can't.
All right. So now we've got 6 equals k11. We've solved. We've got a slope. We graphed our line. Now, I want to know. Now, they'll either give you y or x. Either one. They can flip them around. It doesn't matter. This time they gave you x and told you to find y. They could have just as easily given you y and told you to find
X.
x. What are you finding?
Why?
Another
Point.
point on the line. All right, so if find y when x equals 3. So you're back to this equation, but this time what do I know?
X is trace.
I know my x is 3. What else do I know?
Divided by y.
K is 6 over 11.
Yeah, I know k is 6 over 11, and I know x is 3. I'll put it over 1. Okay, so what does y equal?
9 over 11.
18 over 11. Okay, what's that point? What point did we just find?
Y.
A point has an x and a y in it.
What about a Z? So,
What is it?
18 over 11.
What is x?
3.
So it's 3, comma,
18 over 11.
18 over 11. To check your work, go to your line. 3, 18, and 11 is about 1.5. Is that where my dot is?
3 win.
3. How do you graph a point, Maddie?
2.
Oh.
How do you graph a point? Yep, over
But
3.
why'd you go out 2?
Didn't. It's 18 11. It's almost 1/2. 18 11 is 1
And
point.
your dot just.
Okay, I don't know how that's happening. That I can't tell you. All right, all good? So, step 1, figuring out what kind of graph. Step 2, find k. Step 3, use k to find whatever's missing.
Is that it?
That's it. Go.
Is it step 4?
Mrs. Carter.
Step 1. What do you do? Read it. So it says varies directly, which means
Y
equals k.
K and X.
So y and x. So I know what equation I'm using. So how do I plug this in?
5 equals K 10.
You already did that, Christian.
You divide by 10.
Yep, 0.5.
And then you get 1/2.
Then you get 1/2. So that's really step 1.
That is exactly what.
Okay, could I graph that right now?
No.
Yes.
Actually, yes.
How do you graph it?
I'm on
0.5.
0, go up 1 over 2, down 1 over 2, so it's just a little bit on the other side of this line. Oh, that's really
That's
bad.
very straight.
Oh well, you got the idea. Okay, now I gotta find the next point. What do I do now? Y equals,
1/2 times 2, which is you get 1.
so what point do I have?
So you got half,
2,
2, and then a half.
1.
No, x
Yeah, I put
comma y. The point is x comma y. How are we doing?
Where do you get that?
Oh, shoot.
Wait.
The what? Chris, you gotta talk.
How'd you get the 1?
Because
How do you get one half?
times
What's
2.
half of 2?
Oh.
I
was writing-
What?
So do you just like, or the front, the first number, do you just plug in with your network, or what do you think? That may get. I just wondered how you got the 2 down.
2 down here?
Yeah.
This is X comma Y.
Yeah.
You plugged in X, you found Y.
Yeah, so.
Good. They could have given you Y. You guys, what would this have looked like? Let's do a what if. If I said, instead of this, I said, find X when Y is 7. What would you have done?
You plug in the 7.
So what would it have been?
7.
7 equals
1/2.
1/2
X.
X. How do I get rid of a half?
You
Divide.
times by.
Times by the reciprocal.
So 14.
2 over 1, 2 over 1, so X equals
14.
14. So what would this be here?
14. 14/7.
Beautiful. Are we getting it?
What is that
What is
first
that?
number? It's a K.
No, it's
A
KL.
K1. It's
K1.
K1.
Okay, good? All right, that's direct. The next one is indirect or inversely. They can use both words in there. They can use them interchangeably.
That's too confusing.
So inversely means as something goes up, something else goes down. So the more I exercise, the skinnier I get.
That's actually a false
That is
Indirect.
actually, would you look at this?
You don't exercise.
Actually.
This is part of it. It's actually false. Because you'll weigh more if you
Yeah,
lift
I
weights.
know.
That
That's
was-
the idea. Oh,
that was
I should have
really
said your
neat.
mass goes down, not your weight.
That was
Weight you go
really
up.
neat.
All right.
It was very,
I know.
I like how you got it on
Hey, see that? Okay, wait, something that goes up and something else goes down. Can you think of anything?
Yes.
The more you use the pencil, the less
Yes.
blood you have.
Jacob makes them in the.
The more
you run, more calories you burn.
Ooh, the more you eat, the less hungry you are.
More you run, more calories you burn.
No, that's direct. The more you run, the more calories you burn.
This is harder.
Hold on, hold on.
Indirect.
Oh.
This is harder.
Okay, now someone else brought that up, and that's not quite right. It's not supply and demand, it's supply and cost. Okay, so like, when you think of gas, any of you guys drive yet?
Yeah.
All right, that's gas station. The more oil we have in reserve, the lower the gas prices. So the less oil I have, the higher the prices. That is
Fluctuate.
Yeah, because supply goes up.
Thanks.
As demand goes up, supply goes up.
sometimes.
Yeah.
All right, here we go. So inversely means one goes up and one goes down. So this time, quiet.
We're just gonna look at
Instead of taking KX, they're both on the same side of the equation, because as this one gets higher, this one has to get lower to equal the same number. But we have to solve for y. So how do I get y by itself?
Divide by y.
No.
Divide by x.
Divide by x. So your equation is y equals k over x. K is your constant of variation again. It's just in a different spot. Now these look very, very different than what you're used to graphing.
They do.
So when we go through here, there's also a ratio, they're inverse, so if you have y1 over y2, you flip these guys. Usually messes kids up, so we do it this way. I'm going to teach you this way.
what?
Okay, here we go. Are you ready? You have to read. It says varies inversely. It can also say varies indirectly. It doesn't matter. When you're here, that means it's equal to k over something. That's what varies indirectly means. So that's the first thing you're right. Have you seen your grade? Start paying attention.
Oh.
Now, y, your first variable, goes here. Your second variable goes on the bottom. So y equals k over x. Now we do the same thing we did before. We're going to be given two of them. So we use these two to find what? What am I going to find? Not the y. K. You use the first two to find your constant, then you use your constant to find your
Well,
thing.
why isn't it?
So when we go here, we'll do it over here so you understand. So, it better not be anything I don't like or I'll never talk to you again.
I'll see about that. That's okay. I
Will
like how
we
you got
get
them.
deducted if we put C in our equation?
Yes.
Well, oh, okay.
Okay.
But why
Okay,
can't
here
it
we
be
go.
C?
Now when we look at this, what's y?
1.
1 equals, what do I not know? K over 2. How do I get rid of the 2? Multiply, because it's division. So 2 is equal to K. Step 1. Okay, now I have to find the other part that's missing.
So
So-
like, couldn't you just take the two X and Y and times the
Yes.
instead of doing all
Yep, as long as you don't mess it up.
Well,
All right, 2. What do I do now? What am I
One.
missing this time?
Why?
So y is equal to,
Okay.
2.
what's K though?
2.
Doce.
Over
PD.
5. So what's my new point?
2.5.
Okay, that's,
3.5.
what's
Five.
40%.
Wait, what?
5, comma,
2.04.
2 fifths.
0.4.
All right, are we there? Okay, that's how you find an indirect variation. Now we gotta graph it. This is a little bit different. Is that part
Doesn't it
okay?
just go
Oh. All right. You found K. Is everybody with me? What was K? 2. So this is my equation after K. All right? You have to graph that. Now, I'm gonna make you graph -2 to 2. The 1/2s are in here just to help you understand. They are not something you have to do. Is everybody on this part? Pay attention carefully. Okay. This here is for understanding only. You do not have to do.
Does-
You just have to do the whole numbers. Okay,
So is there like no Y point for C?
wait. Okay,
What they're
this is what we're plugging in. You're listening and waiting. So we start with -2. So I plug in -2 to my equation here. So I'm going to get y is equal to 2 over -2. What is that?
Negative.
-1. So my point is -2, -1. So go -2, -1, and you put a dot. See there? All right, now let's plug in -1. So y is equal to 2 over -1. What does that equal?
2.
-2. So now we go to -1, -2, and we put a dot. Okay, I want you to plug in a half just for fun. So right here, y is equal to 2 over a -0.5. What's 2 over, how many half cups are in 2 cups? 4. So this is -4. So at a half, I'm at -4. All right, you see how that went down pretty darn quick? Yeah?
So, but can it cross the, what is it, the Y or whichever one?
That's what you're waiting. Let's plug in 0. What is y equals 2 over 0? What is it?
0.
What's 2 divided by 0, 0? Try to
One.
calculate.
Isn't it 0?
2 divided by 0 is what?
0.
Divide by 0 error.
Divide by
Zero.
0, error. Why?
0.
How many times does 0 go into 2?
0.
Really? How about 1,000?
How about
0.
5,000?
No, how many times is I can take 0 times.
Well,
anything.
actually, it can go in infinitely, because we'll never equal
Correct.
it. But-
So that's why it's undefined.
So wouldn't there be a
Since
big
this-
blank and then?
Is undefined, this line right here, it will never ever touch.
Wow.
It is
That
called
is awesome.
an asymptote.
Why isn't it called axis?
So, an asymptote is a line, it will, okay, Now, just so you're aware, in other math classes, when life gets a little harder, they can cross these and come back to them.
That ain't right.
But in our life, they will never cross them. It's kind of like a fence. You know how you got dogs that you don't ever want to get out, so you put up a fence so the dogs can't get out, right?
Still get out.
So,
I know. So, this dog can get very close to this line. He can get as close as he wants to the fence, but can he cross the fence?
No.
No.
My cat
So
really
this
loves it.
here
Cops.
will go down
Whoa.
forever. But if he's going down forever, will you be able to tell the difference
Well,
from
wait.
the zero and where he is? Like, could you see it? No. But will he ever touch it?
Yeah.
No.
What?
Think about that.
There are no such things as stupid questions.
Stupid answers.
All right, here we go. Now let's look what happens when I go the other way. If I plug in -3, what do I get?
3.
No. 2 over -3 is what?
A point. Oh.
Negative 2/3 is 0.6, right? Right here. What's 2 over -4? Negative a half. 2 over -5. What's going to happen?
Negative
Gonna get closer.
It's going to get close to what?
A line.
0. Will it ever touch it?
No.
No. So these two lines here divide your graph. They're your asymptotes, your vertical and your horizontal asymptotes. It divides your graph into 4 sections.
X and Y axis.
Not always. It is here because this is as easy as it gets. And it's not going to stay that way very long. All right. So when you look at this one, this graph divides it into, so like this here is either left and right. And then from your left and right, the graph is either going to turn out on the top or the bottom. It cannot be in both places. Fair enough. So if I graph -2 and -1, since I have these below, I know it's going to approach 0 and approach 0. And I'm done.
So the dogs. Oh, so cool.
All right, now let's do the positives. If I plug in +1, where am I?
2.
I'm at 2. If I plug in 2, where am I?
1.
1. So both dots are on the right and the top. Could you sketch that graph in?
Yep.
Yes, because you know it's not going to touch the asymptotes.
So there's more than one dog.
Oh, they're infinite dots.
Dog.
Dog.
Can't they just all unite and knock down the fence?
I have a Okay, do you understand?
Isn't it like a shot
So is this
collar?
like
They're getting
in
closer
No,
and
it's
they're
not
going
like
away
Trump's
and
wall.
they get closer.
All right, your
So
turn.
it's longer than like a brick
You
wall.
have 2. Let's get these graphs and see if you can figure them out. It looks like it. You said varies inversely. You put y equals k over x. You plugged in your y and your x. You multiplied by 10 and k equals 50. Step 1 was good.
Yep.
Okay, now you're on to step 2. And then you have to graph. What is your equation? Your equation is what? Y equals 50 over x. Now, x in this case is 2. So y equals 50 over 2, which is 25. So what point is this?
It's 2, 25.
2, 25. Okay, so how do I graph it? What's my equation for graphing? Is what? Y equals what?
50.
50 over x. If I go down, you won't see the graph. Nope. All right, so I'm going to have to go over here to do it. Let's do 2 of them. Y, x.
Aw.
I can see
Do
that
we
back.
have to do that?
That's x and y. So you're going to plug in 50 over x. So when you plug in -2, what do you get?
Negative 25.
So you get 50 over -2, which is -25. So let's go by 20s. So 10,
25. Go by 25.
No, 30, 40.
Go for it.
So negative 2 is negative 25. What's negative 1?
2.
50 over negative 1 is what? Negative 50. So negative 1 is negative 50. What's 0? Undefined. So what is that? The asymptote. So he's going to approach here and not touch. What's going to happen across the other way is my asymptote going to be?
Don't be the opposite way.
It's going to be on the x-axis.
Uh-huh.
So can I draw this guy in?
Yes. Wait,
So it's like,
So this time, he's a long ways away from the, see how he's farther away than the other guy was? It kind of stretched him down is what it did. Okay, now let's do our positives. What's 1? 50 over 1 is 50. So 1 is at 50. What's 2 going to be? 25. Can we sketch him in? Yes. So I pulled him away from the origin. How are we doing?
pretty bad.
Pretty bad.
Yeah.
What's your question? Pretty good?
Oh, I don't plug anything
My
in.
stomach hurts.
You have to plug in. You have to do negative 2 to 2 to figure out where these guys are going.
So like, that's like a fence. Why are they curving? Not
Any other questions?
Wait, I got another question.
Jordan?
Don't fight, but.
Yeah, where the curl?
You're wasting my time and I don't have a choice.
Okay.
What?
How come we don't find these out there? We just draw.
You can put them in. If you want to find them, you can.
I don't want to do that.
Because they're sketches. We're not graphing these back. That's why. Christian?
Do we always have to do the table thing?
Yeah.
Yes.
Oh, you said.
Okay, here we go. Your turn.
Are you?
Already done our turn.
No. No.